So we're going to wrap up 3.1 with a couple more examples of the chain rule. It's a super important rule and a lot of things can happen with it. So we're going to end with a couple more examples of kind of working with the chain rule. So number one, suppose we have y equals negative 2x cotangent to the fifth of pi x squared minus 3. So wowza, we have a lot to consider here. So the first thing I want us to think about is what is this outermost structure that we have here? And first and foremost, let's always rewrite those trig functions with what they really mean. So cotangent to the fifth is going to mean the entire cotangent function raised to the fifth. And so it was cotangent of whatever's inside that cotan function. Well, here it happens to be pi x squared minus 3. So it's that entire cotangent of pi x squared minus 3 being raised to the fifth. Now, if we look at this structure, I see outer powers in trig functions with inside functions and a negative 2x, but we have to look for what is the outermost structure that we have here. And our outermost structure that we have is going to be a function of x, this negative 2x. So we have a function of x times this cotan to the fifth, another function of x. So this is going to imply that my outer structure, and you wouldn't have to write this out in words, but you sure do have to think about it, is a product. And of course that's going to mean outermost structure for my derivative is going to be product rule. So that's what we're going to jump in with here. And so this would probably be a good time to think about kind of writing out the structure of your product rule, meaning you're going to have an f of x left alone, and then times your g prime of x, and then plus you're going to change that order, and then you're going to have your g of x left alone times your f prime of x. So this is just sort of spread out so I have space. That's going to be my product rule structure. Now let's get into the nitty-gritty details of each of these pieces. So f of x left alone, no problem, negative 2x, got it. Now, times g prime. This is the hardest piece of this whole structure because now I need to look at g itself and think about what is its outermost structure. So g is this cotan to the fifth function. And its outermost structure is it is an inside function, the cotangent being raised to the fifth power. So its outermost rule in this chain rule process is going to be the derivative of the outside with a power rule. So 5 inside function is going to be left alone to the fourth power. So inside function left alone happens to be itself a pretty hideous looking little function for an inside, cotan of pi x squared minus 3. That's the inside function. So it's 5, inside function left alone to the fourth, and now times the derivative of this inside function. So now I have to think about the derivative of cotan of a function. So that inside itself is its own little chain rule. So derivative of cotan of a function is going to be negative cosecant squared of, and now we want to leave that inside alone. So the pi x squared minus 3 left alone, and then times the derivative of that inside. So the derivative of pi x squared minus 3 is going to be 2 pi, this is just power rule, x. to the first. So this is a whole heck of a lot. So I've picked a real complicated one here for working with our G prime. So this is, outermost structure is product rule, but within that we have a derivative of the outside. So this is the primary derivative of the outside times the derivative of the inside. So this is the derivative of the inside. And then within that one is its own little chain rule. So this is another form of a derivative of an outside times the derivative of an inside. That's a lot, right? So this is a chain rule within a chain rule within the outermost structure of a product rule, if you can wrap your mind around that. All right, second term is going to be easy peasy compared to the first one there. So the g of x is the cotan function left alone. And if I'm just leaving it alone, I'm probably just going to write it like it is originally, cotan to the fifth of pi x squared minus 3. And then, so that's the g left alone. And then times f prime, well, the derivative of negative 2x is just negative 2. Okay, so this was my outermost structure here. I'm just going to kind of rewrite it so things line up. So this was my g of x, and this was times my f prime of x. All right, so that is what this derivative would look like. Now, we can certainly maybe just clean it up a little bit. I would not spend a lot of time on this one simplifying. But if you wanted to just how could you get it in maybe a slightly better form, at least in terms of entering your answer? I'm always a fan of multiplying monomial portions together. So in the whole big first term here, we do have a couple of negatives that will multiply to a positive. I have 2x times 5, so kind of in the front there so far, that's a 10x. And then kind of looking down the line, what else did I have at the very end? I had a 2 pi x. So I had the 10x and the 2 pi x and the two negatives multiplied. So that's going to look like 20 pi x squared. So the monomial portion is going to look like 20 pi x squared. And then I'm going to have cotangent to the fourth of pi x squared minus 3 times cosecant squared of pi x squared minus 3. And my last term is just going to be minus 2 the cotan to the fifth of pi x squared minus 3. And yes, you could certainly factor out, a 2. You could factor out a cotan to the fourth of pi x squared minus 3, but we're just going to leave that doozy like that. This would probably not be one that I would give you in the future that you had to actually work with that. All right, let's maybe take a look at one more here. And this one, so we're doing a couple of real challenging ones here at the end. So number 2, suppose we have x squared plus, actually, you know what? I'm going to change my mind on that one. I'm going to hold off on that one for a second. I had a couple of problems listed here. I apologize. I am going to do this one instead. So we'll do one more. This one will be shorter. So just a little more symbolic in nature, but shorter. So suppose we have h that is defined to be f, the fog function. Remember seeing that? That's the composition, f of g of x, but you should know that notation. And suppose that you are asked to find h prime. So find h prime of 5 if f prime of 2 is equal to 6, f of 5 is equal to 4, g of 5 is equal to 2, and g prime of 5 is equal to 6. So sometimes you're given a whole slew of information. Maybe we'll use it all, maybe we won't. So the first thing I need to do is just kind of think about, I'm looking for h prime at a particular point, and I need to first note what h really is. So h is this composition. So h of x, if we want to say h of x, is this composition, and you might have just seen it as f of g. Sometimes we write it as f of g of x. However you've seen that before, this is f of g of x written that way. So g of x is the inside function. All right, so what is that going to mean in terms of finding any sort of a derivative? It's going to mean it needs chain rule because it's a composition. So there'll be times you'll have to work with it more symbolically. So this is how we first wrote out chain rule. So it's f prime, derivative of the outside, of g of x with the inside function left alone, and then times g prime of x, the derivative of the inside. And so that is going to mean that we can sub in now, we're looking for h prime of 5. So we're just going to, now that we have representation for what h prime is, we can go into that representation, and every place where there used to be an x, we can replace it with a 5. And now let's see what the values that they gave me, how those might be useful. So g of 5, that was given, yep, for a second I lost it in the first statement in the second row. So g of 5 was equal to 2, and g prime of 5, also in the second row, that was equal to 6. But I still need to evaluate in the first term there, the first factor, I still need to evaluate f prime of 2. So f prime of 2, that was the first fact given, that was 6. So it looks like in the end, what I end up with here is 36 as my final answer for h prime of 5. All right. So that is it for the chain rule, although it's never going to go away. So we'll be using it all semester.